going to move on to chapter 2. Chapter 2 is all about functions. Chapter 2, section 1 is relations and functions. You have all of today's notes there with you. We're going to do a couple of things here in this section. We're going to analyze relations and functions, and we're going to use equations of relations and functions. The first thing we need to start off with is some vocabulary. There's some words you've got to be familiar with, some of which you've heard before, some of them you haven't. One-to-one and onto, these are new concepts for you. We did not cover these in Algebra 1 or Algebra B. You've got the definitions here, but I want you to add to them. The formal definition of one-to-one function. I'm going to back up. So if we're given a relation of some sort, a table, a mapping, a graph, order of pairs, we need to determine if it's a function or not. And then there's different types of functions. It could be one-to-one, it could be onto, or it could be both one-to-one and onto. Right? So these are all functions, and we're just classifying them a little bit further. So a one-to-one function, formally, is when each element of the domain pairs with exactly one unique element of the range. Underline that word unique, please. Each element of the domain pairs with exactly one unique. Is that mine?
Guess that song though.
I thought it was somewhere over there. I was expecting that.
Unique is a key word here for one-to-one. Focus, please. Focus, focus. I want you to put here, range does not repeat. If we have a true one-to-one function, the range doesn't repeat. Add this to your definition, please. Add this to your slide. If it is one-to-one, the range doesn't repeat. Now remember, if it's a function, the domain doesn't repeat, right? We've assumed all these are functions, and we're classifying these functions a little bit further. A function could be one-to-one if the range doesn't repeat. Onto is when each element of the range corresponds to an element in the domain. Okay? In other words, all the elements in the range are being used. I'll show you what that looks like in a second. Onto function is each element of the range is being used. Okay, and then this third box is just saying it's both one-to-one and onto. So in other words, the range doesn't repeat, and every element in the range is being used. If it's both, those definitions satisfy them, we would just say it's both one-to-one and onto. So we're going to practice deciding whether they're, number one, a function, one-to-one, onto, both, or maybe it's neither. We're also going to look at domains and ranges. Here's our first relation. Remember, a relation is just a set of ordered pairs. Ordered pairs can be written as a graph. They can be displayed as a graph, a table, a mapping, or maybe they're just ordered pairs. So here I've got a graph. It says to state the domain and range of the relation. Let's start with that. In a relation, the domain is what value? Algebra A? Yes, algebra B probably. It's the x-coordinate. The x-coordinate is your domain value. So let's just list it. We have -4, -3, 0, 1, and 3. There's your domain. We're just listing the x-coordinates of each of the ordered pairs. And the range is what? Yeah, it's the y values. So the y values we have are 0, -2, -2, 0, 1, 2, the y coordinates are arranged. Okay, so is this a function? Determine whether the relation is a function is our next step. Yes, how do we know? Good, the domain doesn't repeat. That's very good, Sam. What if we just were looking at the points? And then, sorry. If you look at the graph, you could also do the vertical line test, couldn't you? Does our graph pass the vertical line test? Yes, it does. So it is a function. Okay. So once we're able to determine that it is in fact a function, then we can determine if it's one-to-one or onto or maybe both. So let's go back to that definition of one-to-one, please. The definition that we wrote down was that the range does not repeat. Did we have any range values that were used twice? No, each range value is unique, right? Each is different. So it is one-to-one. One-to-one. We know it's one-to-one. Is it onto? Is each range value paired with something in the domain? Is -2 paired with something?
Yeah.
Paired with 0. Is 0 paired with something?
Yeah.
-4. Is 1? -3. 2. 1. 3. 3. Every range value is paired with something, isn't it? So it is also onto. So it's both one-to-one and onto, so we would state that it's both. Because it satisfies both of those conditions. So the next relation, please. State the domain and range of the relation, then determine whether the relation is a function. If it is a function, determine if it is one-to-one, onto, both, or neither. Okay, we'll start with domain and range. What coordinate is your domain values? The x's, so let's just list them. If they do happen to repeat, do you need a list that repeat? No, just list them once. So -6, -5, -3, -1, 6. Each of those was used once. The range is what values? Y coordinates. So let's list those. -1, -9, -7, 7, -9. Like right here, this is what I'm talking, guys. -9 was used twice. Do we need to list it twice? No, I don't need to list it a second time. Okay, so we listed our domain and range. Is this a function? Does the domain repeat? Did we use the domain values more than once? No, we didn't. So this definitely is a function. Alright, so we determined it is a function. Let's talk about one-to-one and onto. One-to-one, if you look back at your definition, we said that the range does not repeat. Did our range repeat? It did. What range value repeated? -9. Didn't that appear twice in the range? Okay. So it is not one-to-one. It is not one-to-one because that range repeated. Is it onto? Is every y value paired with some x? -9 is paired with 6. 7 is paired with -1. -7 is paired with -3. -9 is paired with -5. -1 is paired with -6. Each y value is paired with something, so it is definitely onto. Let's keep going. Here we have a mapping, same scenarios we've been given. Let's start with our domain. What values would you consider part of the domain? There's your domain. How about range? 6. Is 8 part of your range? It's not. It's not paired with anything, so it's really not. It's not a y coordinate. Alright, so is this a function? You're looking at the domain. Does the domain repeat? It doesn't, so it is a function. It is a function. One-to-one. To be one-to-one, each range value cannot repeat. Does it do any of the range values repeat? Yes. Which one repeats? 6 is used twice. So is it one-to-one? Nope. Is it onto? It's not. And onto definition says that all the elements of the range are being used. Well, we've got a range guide that's not being used, right? So it is not onto. It is a function, but it's not one-to-one, it's not onto. We'll say neither. It's not one-to-one, not onto. Next is table. What is the domain of this table? The x-coordinates, 2, -1, -2. That's it. What are the range values? 1, 2. Is this a function?
No.
It's not. What coordinates do not allow this to be a function? -1 and 2. It's not a function. Okay, so if it is not a function, it can't be one-to-one and it can't be onto. We don't have to go any further. The one-to-one and onto only apply, they're only subgroups of functions. Alright, the next thing that we're going to look at is the difference between a discrete function and a continuous function. There's a relation in which the domain is a set of individual points, like in the graph of A. So let's look at graph A. It is said to be a discrete relation. If it's just dots on your graph, you don't connect it up, they're just dots, we call it a discrete relation. When the domain of a relation has an infinite number of elements, and the relation can be graphed in a line or smooth curve, the relation is a continuous function. So a key way to look at this is if your domain, the domain is a set of individual points. We can list the numbers in our domain, then it's discrete. If our domain is a set of infinite number of elements, like all real numbers, we call it continuous. That helps you distinguish between the two, discrete and continuous. So look at the next slide. It says the table shows the average fuel efficiency in miles per gallon for SUVs for several years. Graph this information and determine whether it represents a function. Is this relation discrete or continuous? Well, I think if you look at the next slide, I've already graphed it for you, correct? Would your domain be a set of individual points, or would your domain be all real numbers? What is your domain for this graph going to be? Change with us? What's your domain going to be, guys? It's going to be individual numbers. It's individual points, it's numbers. So what type of function are we looking at? Discrete or continuous? It's discrete. It would be a discrete relation. It also asks us, is this a function? Well, does it pass the vertical line test in order for it to be a function? You draw a vertical line anywhere and only touch one dot? Yes, it is a function. This next slide says the table shows the average weight of a baby for several months during the first year. Graph this information and determine whether it represents a function. So look at the next slide. There's 4 choices here. Let's just talk about it. Which one of these graphs best represents the points that are plotted? First point is 1, 12.5. They're all about the same. The second one is 216. This one doesn't even have a point at 216, does it? Hold me with us. I'm going to cross off B. C doesn't have a point at 216 either, so I'm going to cross that off. So it's between A and B. A and B looks like the graphs are pretty well identical. So, is this a function?
Yeah. Yes.
It is a function. It passes the vertical line test. A would be the correct answer. Would this represent a discrete or a continuous relation? Discrete. Your domain would just be points. Your domain is points. Alright, couple more guys. We're almost done. It says to graph y equals 3x minus 1 and determine whether the domain and the range. Then determine whether the equation is a function, is 1-to-1, onto, both, or neither. State whether it's discrete or continuous. We haven't talked a whole lot about graphing yet. We'll get there, but we're just not there yet. So let's kind of play it safe. When you first learn to graph lines, you probably use an XYT chart to begin. Am I right? One of the first ways you learn to graph. So if we put -1 in for x, 3 times -1 is -3, -3 minus 1 is -4. Put 0 in next. 3 times 0 is 0, minus 1, -1. Put 1 in. 3 times 1 is 3, and 3 minus 1 is 3 times 2 is
6.
and 6 minus 1. Okay. So we've got some points. Let's go ahead and plot these points on our graph, if you would. I know the graph's not very big. Do the best you can. Make sure you draw your line through your points. This is an equation, right? It's a linear equation. Why did we draw the line through this one? And these last few, they've just been dots.
Continuous.
It's continuous. The domain, we put anything we want in for x. Okay? The domain gives you a lot of information on that. This would be a continuous function where we would need to draw the line. It is an equation. So the first thing, it says to find the domain and the range. Well, what would be your domain?
No.
I agree, these are part of your domain, but we're not limited to these
Just
numbers.
staying in.
Right. We can put anything we want in for x. The domain is all real numbers. What about the range? Could we get any number we want out of our range? Okay. Guys, the domain and range of any linear function, any line, is always all real numbers. Remember in Algebra B we talked about smashing a graph on the x and y axis for domain and ranges? For the domain of this, if we take our graph and we smash it on the y axis, take our graph and just put it on our y axis, the whole number line would be covered. Same thing with the x-axis. We could take our graph and kind of swing it around, get it on that x-axis, the whole thing would be covered. Okay, so is it a function? I should ask you that.
Yes.
Absolutely, it's a function. It passes the vertical line test. Is it 1-to-1? Can the range value repeat? Can I get 5 out any other way other than putting 2 into my function?
No.
No. You put one number in, you get one number out, you get a unique number out. It is 1-to-1. You can't get the y values twice. One way to get 5, put 2 in. One way to get 2, put 1 in. Is it onto? Is every value, every y coordinate matched up with something in the domain? Yeah, it's matched up with something. It has to. It is onto. So if it's 1-to-1 and onto, what do we say it is? Say it's both. And is it discrete or continuous? It's continuous. I think the next slide actually has it graph. Let's see that. Alright, I'm gonna stop here. We've covered a lot of stuff today. It's not difficult stuff, you just gotta know your definitions, gotta know your words. If it is one-to-one, can someone raise your hand and tell me what one-to-one is? What's one-to-one? What's one-to-one?
Range doesn't have to.
Range does not repeat. What about onto? Yeah, every value in that range is matched with something in the domain. Discrete. What's discrete?
Points.
Just individual points. Your domain is a set of individual points. And continuous?
Vertical.
Straight line. It would be some kind of smooth graph where your domain would be all the numbers. There may be some problems tonight where you're going to have to do some graphing. Just draw yourself an XY axis and plot your points.